All right, this is 4.1. We're going to talk about exponential functions. We're going to talk about logarithmic functions. We're going to talk about logs and stuff like that later on. But you guys will be allowed to use calculators, okay? My suggestion to you, right? We have a quiz next Thursday, the 27th, over 414243. It happens to be my birthday, but it's all good. You will be able to use a calculator on it, but I strongly suggest that you get a calculator before then so you know how to use it. You don't have to buy a fancy, expensive graphing calculator. You don't even have to buy a calculator if you want to borrow from somebody, but don't come in the day of the quiz and sit down and go, I don't know how to use this calculator. Hey, Ms. Menace, can you help me real quick? I can't, okay? You have to be familiar with the calculator. Right now, if you're using your iPhone, it's a little different than a lot of the scientific calculators that you have. And again, you can't use it on your test, so make sure that you guys have something to use. So exponential functions, guys. All right, we're going to talk about what exponential functions look like, how to evaluate them, all that good stuff. But unfortunately, a good real-world example of an exponential function is coronavirus. It started off with just 1 or 2 people, and then it was like 20 people, and then it was like 200 people. It started off with a small amount, and then it grew really quickly. Okay, that's kind of what exponential functions do. This is what an exponential function looks like. All right, we write it in f of x, our function notation, but notice it is comprised of, it's made up of a base. This is going to be a number. And then what is in the exponent? What is that? It is a power, but what is that? Is that a number or is that a letter? It's a variable, okay? When you guys have your exponential functions, your variable is in the exponent. That's what makes it an exponential, okay? Everybody with me? Okay. You will notice that you're going to have 2 kinds of exponential functions. You're going to have growth and you're going to have a decay. We're going to talk about this in a minute. But a growth function, you might want to write this down, and we might write it down again. A growth function has a base that is greater than 1. Right? Anything, if you had 1 to the x power, that's just a constant function. So an exponential growth will be 2 to the x, 3 to the x, 4 to the x. An exponential growth looks something like this. It's kind of a shape. From left to right, it starts off slow and then gets bigger in a hurry, depending upon the size of the base. The bigger the base, the faster it grows. Everybody with me on that? Okay. Here are some examples of exponentials. How do I know that these are growths? What are the bases? They're bigger than what? Bigger than 1. 2 to the x, 3 to the x, 10 to the x. If we were going to plot these, if we were going to actually draw them out, you would plug in values for x. 2 to the negative 2, 2 to the negative 1, 2 to the first, 2 to the second, 2 to the third. You can plot your points. You see how it grows, okay? Now, there's going to be different transformations to your graph. Your transformations are exactly the same as your transformations from every other function we've done. If I had 2 to the x power, right? Is that a growth? Yep. What's my base? 2. Okay. If I had this and then I said plus 7, where does that move my graph? Up 7. That's a vertical shift. Very good. Moves the graph up 7. What about if I had f of x equals 3 to the x minus 4? The x minus 4 is in the exponent. It's with the x. When we had shifts that were with the x, where did it go? Up and down? Side to side. Which way is this one going to move? To the right. Why is it to the right? It's the opposite of what you think. Good. All right. Anything at the end, adding or subtracting at the end, is going to move our graph up and down. Anything that's inside with the exponent, it's going to be our left and right. What about if I had... What does that negative sign do? Ooh, Oh, very good. It's going to reflect over what? Very good, over x. What if the negative was up here? It reflects where? Very good, guys. Reflects over y. Same exact transformations that we've had before, because it's just a different function, but it's the same setup of our transformations. What about, let's see how good we are, if we had f of x to the what's that 1/2 in front do? Vertical what? Vertical shrink. Good. If it was a whole number, it'd be a vertical what? Vertical stretch. What about
horizontal?
a horizontal what?
Shrink.
Very good. How come?
It's the opposite.
It's the opposite. Horizontal shrink or compression. You would think it's getting bigger because it's bigger than 1, but anything with the x is the opposite of what we think. Good. So all of our transformations still hold true for all of our functions. This just happens to be an exponential function. All right, you guys with me? All right, moving ahead. Let's do some evaluating. What does evaluate mean? Solve it, right? Evaluate means to solve. So if I gave you guys these problems and I said, here, evaluate, and I needed you guys to show me some work, this is what you would show me. You'd say, okay, for letter A, 3, what do they want me to do with 5? Plug it into the exponent, 3 to the 5th power. Now, some of you are looking on your calculator and you're like, how do I do raised to the 5th power? Okay, there's a little button called a caret. It looks like the top of an arrow. That means raised to. Like, some of you have like a little XY button or something like that, but if you have 3 to the 5th power, what is 3 to the 5th power in your calculator? 243. Now, at any time that we do this, you guys do not get the same answer as me. There's no reason to put your head down. Like, oh my gosh, I can't believe I don't know how to use my calculator. Just ask me, right? Everybody's calculator is different. If I don't know how to do it, I will figure it out and I will show you. But if we look at B, okay, B is a little different. B says 3 to the negative 2/3. I love you guys dearly. Some of you will come up to me and say your calculator is broken. All right, your calculator is only as smart as the user. You have to tell the calculator what to do. When you put this in your calculator, you have 3, then you hit that caret button. Then you have to put your exponent in parentheses. It's negative 2 divided by 3, and you have to close your parenthesis. Now, there is a difference on your calculator. There's a negative button that changes the number from a positive to a negative and vice versa. And there's a minus. You cannot use the minus button. It'll tell you error. So you need to hit 3, then the caret, and then parenthesis, negative 2 divided by 3, close your parenthesis. What do you guys get? So 0.4807, something like that. And I'll tell you what's around to. So letter C, you're plugging in pi. So it's 3 to the pi power. What do you get when you take 3 and you raise it to pi? 31 point what?
5.
Just 5?
54428.
544. Okay. Anybody agree? Disagree? All right, if we have letter D, I'm going to take 3 and I'm going to raise it to the square root of 2. That's not 3 squared, guys. It's 3 to the square root of 2 power. What do y'all get? 4.728. Okay, good. All right, so really straightforward questions. If I give you a question, I say evaluate, it means plug in. Y'all have to know how to use your calculators. Very, very important. Questions? Go ahead and go to this slide, guys. We're not going to plot points right now. We'll talk about graphing a little later on. But do you visibly see the difference between these two problems? Are they both exponentials? Yes. Because where is the variable? Where is the variable? It's in the what? What do we call that? It's where the exponent is, right? That's why it's an exponential, when you have a variable in the exponent. So if you look here, you guys can tell me, is this a growth or a decay? Look at the base. Is it a growth or a decay? It's a growth. This is a growth. So it's going to, from the left-hand side, it's going to start kind of slow and then move up as we plot points, as we plug numbers in. Letter B is what kind of a problem? Why is this a decay? Because that number in between is less than, it's between 0 and 1. So it's going to start up here and come down here. Is there a way, guys, that you could have a decay that graphically looks like a growth? How? If it was flipped, good. If there was a reflection. So just because you guys see a fraction, don't just in your mind go, oh, the graph would look like a decay. Because if there's a minus sign in front of it, or if there's a minus in the exponent, it could flip it over the x-axis to the y-axis and then change the look of the graph. So it's really important to plug in x values. If I was going to ask you to find the x-intercept, how would you guys find the x-intercept? What would you plug in for y? 0. Okay, we don't know how to do that yet, but we will in upcoming lessons. But if I asked you to find the y-intercept, how would you find that? Plug in 0 for what? X. So if I plug in 0 for x here, and I plug in 0 for x here, in both cases, what's the y-intercept? It's at 0, what? 1. Anything raised to the 0 power is 1. Question, Joseph. All right, let's look at this. This is a good visual representation, okay? If we have our functions here, on the left-hand side, what are all of these functions? How do you know? Because the base is between 0 and 1, right? So do you see how they all start over here and they come down and get close to the x-axis, yes? Over here to the right, all of these are what kind of functions? Growth. They start over here on the left-hand side real close to the x. This is going to be an asymptote. And then they grow depending upon their base value. Depends on how quickly they grow. But what do you notice they all go right through? Y-axis at where the point is y there. Because we're not moving it up or down, left or right. There's no shifts anywhere. It's just a basic function. So your basic exponentials that don't have any shifts are always going to go through the point 0, 1. That's pretty much what I just said right here. Same thing. Same thing. All right, here, let's talk about compound interest. This, guys, is super duper important. We're going to do a couple examples here. All right, we're going to talk about compound interest. You guys are going to have word problems. You're going to be given an initial amount of money to invest and blah, 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 blah. This formula needs to be committed to memory. You will not be given this on a test or a quiz. You guys need to know it. There's different pieces of the formula. We're going to go through what each piece means. The P is your principal, okay? It always goes right here outside. You're multiplying it by whatever's inside this whole parentheses here. But your principal is the initial amount. It's the initial amount. It's what you start with, if you want to say that. What you start with. All right? Your principal, your P in the formula is what you start with, the initial amount. Now, secondly, this is so super important, your R. You see your R right there? Your R is your interest rate. Everybody's seen that before. You get on car commercials, they talk about APR, financing, blah, 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 blah. But right here, so important, must be in decimal form. When you go to compute your answer, you have to convert the interest rate into a decimal. So if I gave you the interest rate of 15%, how do we change 15% to a decimal? What do we do with the decimal point? You move it over 2, right? You divide by 100, so this would become 0.15. That makes a very big difference, guys. When you're plugging in numbers into a calculator, if you're multiplying or dividing by 15 versus 0.15. Huge difference in your calculations. So be careful. If they give you an interest rate of 4.72%. Okay, they give you an interest rate of 4.72%. Is that already in a decimal?
Yes.
Well, I see a decimal point, but what's right after the 2?
Percent.
A percent sign, so it's not a decimal yet. How do I turn 4.72% into a decimal? I have to move that decimal point. So this really becomes 0.04, right? 72. Huge difference in calculations between 4.72% and 0.0472. You guys see that? Okay, I'm making that a very super duper important point. All right, then we're going to talk about N. This is the number of times the interest is compounded per year. This is how the interest is compounded. They're going to use words like annually, semi-annually, monthly. What does annually mean? How often does something happen if it happens annually? Once, right? Once a year. What happens if something happens monthly?
Every 30 days.
Okay, every 30 days, but how many months are in a year? 12. What about if it happens quarterly?
Every 6 months.
Not every 6 months. 4, right? Cut $1 into 4 pieces. A football game into 4 pieces. A year into 4 pieces. It's 4. If I said something was compounded daily, what is my N value? 365, okay? That's what you guys are going to have to really pay attention to. You need to know what those words mean. And then the last part of our formula is right here. And that would be our time. And time is going to be in years. Okay, so like I said, this formula will not be given to you. You guys are going to have to know it. So make sure that you are practicing this. But let's do some here. All right, I have one word problem. Correct? You guys see that? But I actually have 5 different word problems. Why? Because, yeah, what does the chart say? It's changing what value? It's changing our N. So you have a sum of $1,000 invested at an interest rate, okay? Find the amounts after 3 years if the interest is compounded annually. Then find it semi-annually, then quarterly, then monthly, then daily. Are all of those numbers going to be the exact same? No. They will not be the exact same, but I do want to go through this with you. I want to show you some things to make sure that we're on the same page here. We're going to do together annually, quarterly, and daily. Okay? We're going to do those 3 together. So I'm going to write down my formula again, just to make sure that I remember it. And it's my principal times 1 plus rate divided by n over n times t. Correct? Did I write that correctly? Everybody check me? Okay, so we're going to do it 3 different ways. We're going to do it where it's compounded annually, which is 1, quarterly, which is 4, and daily, which is 365. So guys, if you have a calculator, you need to get it in your hand. And we need to do this together so you guys make sure you understand how to do this in your calculator. Now, there's some information that they told us in this problem that we're going to use for each problem. What is the initial amount of money that we're investing? $1,000. So in every case, my P is 1,000. Everybody see that? Did not change. I'm investing $1,000. I want to see how after 3 years, how the amount changes of what I have accrued. They give me an interest rate. What is the interest rate that they gave me? 12% per year. So my R is what? 0.12. Perfect. Again, if you put 12 in with your calculations, your problem is incorrect. So make sure you guys are paying attention to that. Okay? Our N for each scenario is different, correct? So here my N is 365. What is the time that they told me?
3 years.
3 years. So t is 3. T equals 3. And t equals 3. All right, calculators, get ready. We're going to do this together. I'm going to talk to you about some things. The initial amount you put in is $1,000. We have our 1,000. Then I have 1 plus what? 0.12, good.
Divided by 3.
Divided by, what's my n in this case? 1. And I'm raising that to the 3 times 1, right? Now, the reason I wrote it like this is for a couple of things. First thing I want you guys to understand is when you put this in your calculator, you have to have a double set of parentheses there. You have to put this in the calculator exactly like you see it. It has to say 1,000, parenthesis, 1 plus, parenthesis, because you have to do that division before anything. If you don't put that parenthesis, you're not telling your calculator how to work. You need to work from the inside out. Now here, I understand in my power, you guys know that 3 times 1 is what? 3. You don't have to put the 3 times 1. If you want to just put 3, that's fine. But know that if you have two numbers that you're multiplying together in the exponent, you have to put it in parentheses. So in your calculators right now, if you have like Sophie's pink calculator, or Joseph used my blue one, or Arthesia, if you have the graphing calculator, everybody with me, put 1,000, parenthesis, 1 plus, parenthesis, 0.12 divided by 1. Then you have to close the parenthesis, and raise that to the third power. And tell me what you get. We're talking about money, so don't give me 27 decimal places. Just 2. What'd you get? Tell me.
$1,404, and you could round it to 93 cents.
Okay, that sounds good. $1,404.93. Now, if you got that, congratulations. If you did not, like I said, do not put your head down in shame. Like, oh no, it's okay. Just figure out where we went wrong on our calculator. Does anybody have any questions about how we got that? Okay, so we're gonna do the same thing. Say it again.
Do we need to,
Okay, let's do the next one, all right? We're doing the exact same problem, but instead of compounding annually, we're compounding how? Quarterly. Yeah, I mean, you guys can do all of them. I'm just going to do the 3. So quarterly. So I'm going to say, okay, I'm going to take my $1,000, 1 plus my 0.12, but instead of dividing by 1, what am I dividing by now? 4. And then when I raise this, I'm going to raise it to the 3 times 4 power, right? What's another way I could write 3 times 4? I could put 12. But remember, this fraction in here has to go in its own parenthesis. So you're going to say 1,000, parenthesis, 1 plus, parenthesis, 0.12 divided by 4, close that parenthesis, then close the big parenthesis, and then raise it to the 12th power, or to the 3 times 4. What do y'all get? All right, hold on. 1,425. And how many pennies?
76.
76, 77, something like that. Okay. All right. How do we feel? We all right? Okay, let's do the last one then. We're going to do the exact same thing, same amount of money that we're putting in, same interest rate, same time period. But now, how are we compounding our money? Daily. So for n, I'm going to plug in 365. So I have 1 plus 0.12 divided by 365. And I'm going to raise that to the 365 times 3 power. It's a big number, and that's okay. But remember, this fraction here needs its own parenthesis. So go ahead. What do y'all get? Tell me.
I got $1,433.24.
$1,433.24.
Yeah.
Okay. We get the same thing about? Yes, no? Guys, no? Joseph, do it again then. All right, guys, what I want you to notice, what do you notice about the values of these 3 numbers? It is increasing by a lot. Is there a huge difference between the annually and the daily. Think about that. Once a year, the interest is compounded versus the interest being compounded every single day. The difference is about, what, $28? What you guys need to understand and what you should see and what you should be aware of as you're doing this is we put in, we're not investing in cryptocurrency or anything like that. We put $1,000 in the bank, right? And at the end of 3 years, it should make sense that it went up about $400. You will have problems. I guarantee you guys are going to get problems where you invest like $2,000, right? And you might have an interest rate of 4.3%, which is low, right? 12 is a lot higher. And then you guys work this out and you tell me that after 4 years, you have 1.3 times 10 to the 7th power. That's a large number, correct? If you get something like that in your first of all, I'm not going to give you anything where you work something out and you write it in scientific notation. Secondly, it should make sense that a fund will not grow that much in a little bit of time. What probably went wrong when you were doing something in your calculator? What could you have possibly forgotten to do, you think? Maybe move the decimal point. Maybe you put one too many zeros in. I'm saying this because this happens every single year. You need to just be super careful. If you need to do a problem 3 and 4 times, do it 3 and 4 times in your calculator. A lot of us aren't used to using calculators, right? Which is just kind of an intro. So we need to make sure that we know how to use it. We know how to input. So I cannot impress upon you enough how important it is to get a calculator and be familiar with it. If you don't want to buy your own, that's fine. Just borrow from somebody and borrow from them every day so you have the same calculator to use from and that you're familiar with it. If you have questions, you need to come and ask me. It's no problem at all. I will help you. Everybody, we good? Okay.